Hello friends, my name is Tony and welcome to my garage. About 5 years ago I decided to build a CNC machine. Sorry, I'm not very good about video things, but I just thought I would share this with you guys. And as you all know who does CNC, sometimes it's a real challenge to clamp your jobs onto the table. And I've done lots of methods, I've built lots of ways. As you can see, I've got rails on my table on my sacrificial board. So I clamped the jobs as well as if I need to use my 4-axis drive. But it is a challenge, and sometimes you have to use screws. And the challenge is, once you put clamps, how do you cut the board on top without hitting the clamps, and so on and so forth. So a couple of weeks ago I was listening to some guys on YouTube, and one of them designed these clamps, which is quite a brilliant idea, and it works honestly very well. So I 3D printed them. I've put some stoppers here on the end, so if you want to do the same work over and over, you can carry on. You don't have to reset everything. You just put a stopper there. You can put a stopper on the back, on the side. I 3D printed this manifold, and as you see, with the pipes and the vacuum pump, it works perfectly. As you try to do other jobs, new challenges arrived, and so I designed with Aspire a board after watching and observing a couple of people and doing their vacuum pads. And so I created this one. I made this one up with marcenite, or FDM as you guys call it. And it works. Very small, it was just a test. And then I decided, now I'm going to make a proper vacuum pad. And so this is a piece of Visconite that I have purchased. And truly the serious challenge is to drill these holes that connect onto the ports. I've got 9 ports here. So here I had to take it to my machine shop, and being in the engineering and construction sometimes makes it a little bit easier. So what we did, we put it on our milling machine, and using this drill bit, a 12 millimeter drill bit, sorry, a 10 millimeter drill bit, we drilled it up to there, to the middle, and then from that side we drilled it again, and the holes met together. And then it's just a matter of putting the board on a table and then set up and drill your ports. I 3D printed these plugs because I don't need them right now. But if in future I need to make another board, I will just connect these plugs onto the next board, and now you've got a fully workable vacuum pad. So once again, I 3D printed this manifold, so you can have different connections and you don't have to keep on changing them. So I just have to undo those. I need to purchase another 2 valves, and then you can just interconnect them, open which valve, use which valve you want to use. As you can see now, the vacuum is 0, and I've just done now this board, which I'm now going to use as a sacrificial board. So what I'm going to do right now is I'm going to experiment. I have already machined half of the board because I couldn't get a 6mm board. So I took a 16mm, 18mm, and I'm busy machining it down to 6mm. As you see, the pressure is 0 right now, so the board moves easily. And once I activate the vacuum pump and I press on the board, the suction kicks in, and now this board cannot move. You can see I'm pushing this board with all my might and is stuck there. So it works pretty good. The challenge is when you buy the visconite might not be equal. And I should have machined the visconite to be aligned with the CNC bed, which I didn't, and we learned by our mistakes, and that is why sometimes it's good to share this with everybody that does CNCing or that is trying to create a vacuum table. As you can see, like I said, the light is coming through, which means that this board is not 100% straight. And so the sacrificial board cannot come right to the edge. I'm using now the inside, which is the straightenest piece of this board. So what I'm going to do is I'm going to turn this board upside down, clamp it onto the table, and machine the back first, and then turn it upside down again, remove all the rubber seals, and give it a 0.2 or 0.3 machine, depending on what it is required. If we do the same test, you can see I've machined the table, the sacrificial board, before applying the vacuum board there, and you can see there is no light coming through, which means this table is perfectly straight. I'm now going to remove all the screws that are holding the vacuum board onto the table, so that I can machine it. So what I'm going to do right now is, because as I mentioned earlier on, the clamps are in a way, I will go and bore these holes using the same template as I built this, just by 8mm deep, so I can put some cap screws into it and then hold the board down without interfering with the machining, which I will do later on. So I'm working from the center of my table, and right now what I'm going to do is I'm going to auto tool 0 my bit.
Tool 0 complete.
Okay, so now that these holes are drilled, I've removed the clamps, the holding clamps, and I'm going to put some of those rail nuts so that I can hold the board down and then machine the top, as I mentioned earlier on. So last night I decided I'm going to use a clock gauge to see what is the difference between the center of the board and the edges. So I 3D printed this adapting bracket. This bracket, as you see, it fits on a clock gauge, and then it's going to fit on a machine like that, and that will give me a chance to see what is the difference and how much I have to machine on this board in order to get it straight. So I want to show you, if you can see there, this is on 0 now, the clock gauge. So I'm going to move the clock gauge to the right, to the center of the board, and as you can see, that is the difference between the edge and the center of the board. Now that we are on the center of the board, you see that the clock gauge there has moved from 1 to 0 on this edge here, which means this board from here to the edge is 1 millimeter out. So today I've got two future engineers here with me, my grandchildren. They came to visit, and they are going to help me to set up this board. Am I right, children?
Yes.
So now we are going to see what is the difference in a board across. So as you can see there, the clock gauge is on 0. I'm going to now move it over to this side, and you can see already it is moving. As you can see, it's going to drop now. Most probably it will go to 0 again, and there you go. So we are on 0 again, which means from the center of the board to the edge, we are 1 millimeter out. Okay, so what I've realized is, first of all, visconite it creates its own memory. So when you cut it on opposite hand, the visconite literally bend to itself. Now that it's being on a table since yesterday, it looks like it has somehow straightened. I'm going to drill two holes here. So for a M6, it's 5 millimeters. So what I'll do is I'll tap 4.5, because this is not marstenite or MDF like you guys call it. This is shutterboard, which is much stronger and it's got more resistance to threads. So I will drill then 4.5 millimeter and put the tap, 6 millimeter tap in. The only thing I want to is just to push these two centers of the board down so that it doesn't have such a bend. After checking the board, I've decided now that I'm going to auto tool 0 on the corner here, because the center is higher. So if I auto tool 0 at here, it's the lowest point, the program starts cutting from this corner, which is on the edge, and goes from here that way. So therefore, if I auto tool 0 it on the lowest point, then it should cut very little here and then carry on cutting gradually into that side. Let's have a look and see if it does that.
Tool 0 complete.
So while that is cutting, I would like to show you a vacuum system. A lot of people battle with a vacuuming the hood that we do. So what I did is I created this vacuum that works 100%. So this is my vacuum system. So as you can see, I've got a normal vacuum cleaner, and I've put that drum in there, created a trolley, and so it sucks from the CNC. So the pipe sucks in here. There's a pipe going from the top into the vacuum cleaner, and as you can see, all the shavings goes into the drum. I only need to empty the drum once in a blue moon, and with the amount of work I do, obviously. And in the vacuum is only the fine particles, the fine dust that stays in there, and you can just clean that filter every so often that you feel is required. We just finished doing this pass. I'm just gonna take a deburrer and clean the edges, and then we do a test again on top with a straight edge to see if this is now straight. I've just turned the board upside down, and I've put the clock gauge, otherwise the video is going to be too long, much too long. And we've got exactly the same problem as we had on the back, which is 1 millimeter difference from the center to the edge. So what I'm going to do now is I'm going to zero it in the center, which is the lowest point, so that it can skim from here off by 1 millimeter. We have, as you see, finished machining this board. I'm going to now have to deburr all these squares, because it will leave pieces of plastic here, and then the seal will not work properly. I'm very glad to say that it came out very, very nice. So I would like to show you that there is absolutely no light now coming through. So that tells me this table is 100% straight. And as if you can remember, early on I could not put a bigger board here because it wouldn't suck due to the fact that it was touching on the edges. So now let us have a look and see. I got a bigger board here, and I'm going to put it on top here right now to take the whole length of the table, and let us see. And there you go. 0.8. This table is now cannot move nowhere. It's totally fast. The board is fast onto the vacuum pad. I'm just gonna do an auto tool 0, and then I'm going to give it a skim of 1 millimeter. So as you can see, this board looks beautifully straight. The pressure still remains the same. It's 0.6 CF, which is great. What we're going to do now is we're going to put a straight edge, and we're going to do a test to see if it's straight. There we go. We've got our straight edge there, and as you can see, not a bit of light is coming through. It's telling me that board is 100% straight. The idea of this board is to use it without actually hitting the real vacuum pad. That is another subject that we will we will touch. I'm going to now turn this board around and so on and so forth. But anyway, the point, and his friends, there are many people that think that they are incapable of doing a project, and truly that is not the truth. With the resources that are available out there today, there are a lot of people like me. I do this to help others to not struggle like I struggle sometimes. And you can really do it if you put your mind to it. You can do a vacuum pad with MDF if you want to. I personally feel plastic is the best way to go. I wouldn't use visconite again, because visconite it's a soft plastic, it's got a memory. So I would need to do some research and find out what would be the best plastic to do it. And the learnings truly is to first machine your bed. Make sure that your spoil board is 100% true, and then machine your plastic, whatever plastic you're going to use, both sides before you even attempt to cut your pattern, whatever pattern you are going to use. I'm going to now make this is just an experiment, because what I've heard and the concept behind is that MDF is porous. The reason that why I use the plastic, and that you then can use this as your vacuum pad, as your sacrifice board, so you don't have to touch or machine into the seals. If you have to machine something through it, you're going to definitely damage the seals, and there is your hard work vacuum pad gone. But truly, you can do it. If you put your mind to it, nothing is impossible. So, sorry for the long-winded video. It is my first time, like I said from the beginning. I've never done this before. For me to talk in front of the camera and to try to explain to somebody, it's a little bit difficult. But nevertheless, thank you for your attention. If there is any comments, please place it at the bottom. I would like to hear your input, and I'll definitely make another video just on the subject of this spoil board, which I'm definitely going to try it and try and make it work. Thank you so much. All the best. Bye-bye.